This is an elastic rubber band, right?
Oh, I do remember.
It's very similar to the springs that you've been using in the lab. And if I vibrate it, it oscillates at a standing wave, right? What's fantastic about natural systems is that if you take any natural system and just bump it and add energy, they almost always will vibrate at n equals 1. So if you think about any stringed instrument, when you pluck the string, it is naturally vibrating at the fundamental frequency. Fundamental meaning F equals 1, right? F1, the first standing wave, n equals 1, is the fundamental frequency. It's also called the natural frequency because of the fact that any natural system oscillates at n equals 1 standing wave, right? So in this case, I'm just putting the energy in once, and we're just watching it happen, right? But nevertheless, that is half a wavelength that I could then figure out wave speed and other things by measuring the length from this to that, right? This system is basically a speaker, right? It has a magnet on the bottom that pumps up and down the way a speaker would. So I have this box that vibrates at a particular frequency. If I turn this down to, say, 3 hertz, right? 3 hertz. This thing is oscillating up and down 3 times every second. And you can see that the string is vibrating, but we don't really see anything interesting. Now the thing is it doesn't vibrate very far, so we're not getting good, pretty wave pulses like you were doing in your spring, but that's because this is an electronic system and not a big, massive spring, right? But if I adjust this, which I figured out this morning, to 6 hertz, then the amplitude in the middle gets pretty big, and it starts to oscillate at n equals 1. Right? So through experimentation, saving time, I already figured out that the fundamental frequency of this system is 6 hertz. And I can see that because I see a large area of constructive interference in the middle with it dying off on either side, right? It looks like a jump rope. This is your n equals 1 frequency. Make sense? The wave that is being put in over here is reflecting off of that end, meeting back over here at exactly the same moment that the new wave is coming off of this and meeting in the middle. And so they're both positive, which is causing the whole thing to be more positive. And then exactly the opposite of that. The wave that's underneath is meeting the wave that's underneath, which is why it bends down. So it goes up and down and up and down and up and down at that frequency. The amplitude grows because it's more than one wave, right? That's why it looks so much bigger, and we can actually see it moving than when we were doing at 3 hertz. But now that I know that the fundamental frequency is 6, right? The second standing wave is going to happen at what?
12.
At 12. So if I go up, right, at 9, you can tell that it's moving around, but we start to get irregular patterns. It's not really clear. If I go all the way up to 12, right?
Oh.
Then I get a real clear distinction of one big peak right here, one big peak right here, and look right here. It looks like it's not going up or down because it's not going up or down. Because at exactly this spot, the reflection from over here has a positive amplitude and the input from over here has a negative amplitude, and so every single time the two waves are overlapping right here and canceling out. But it's not destroying the energy, or else the thing would not be vibrating, right? So this is your n equals 2 standing wave. So then obviously the third standing wave would be at what frequency? 18. So if we go up to 18, right?
Whoa, that's crazy. It's
Now we see 1, 2, 3 areas of constructive interference, and 1, 2 of destructive interference. And technically there's actually 2 more, one at the end and one right here at this end, right? So 24 would be the next
60?
one, right?
That's crazy.
And so now we get 4, right? Yeah,
You
very,
can't really
very
see
clear.
them.
You can definitely see that these are not moving, so
Well, yeah.
that's the indication, right? So we can clearly see that, right? And so obviously the nice thing about this is that it's electronic, so the next one would be 30, right? So we go up to 30,
Whoa, that's so cool.
and we get 5,
So fast, you like
and so on and so on and so on and so on, right?